human brain is one of the most complex and fascinating structures in the known universe. For hundreds of years we've been trying to understand it. By observing behaviour of humans, we can start to guess its function. And by dissection at post-mortem, we can start looking at the underlying structures. So the tissue that provides that function, and the vasculature, the vessels that support that tissue. But these models, these methods for looking at it, are very limited. If we're looking at something like disease, Alzheimer's disease, we can observe the changes in behaviour of people. And at post-mortem we can see degradation in both the vessels and the tissues. But which one comes first? We can't answer these questions with a single time point. Fortunately, modern imaging allows us to look at the brain over time and see some of that development. And with diffusion MRI, we've been able to model all the neurons in a network. But until recently, we've only been able to look at the large blood vessels. Susceptibility weighted techniques have allowed us to look at the microvasculature by looking at iron specifically. And now we can see both the small and the large vessels. We can start looking at the vasculature as a whole. And that takes us to my PhD. I'm trying to quantify the changes in the vasculature in the human brain and look at how that affects aging and Alzheimer's. And my approach is to look at this network the same way we look at a road network in a city. How do the characteristics and efficiencies of that road network affect the usage? And how does the change in usage over time affect how those roads are maintained and developed? How do they change shape? My approach is to take modern image processing, machine learning and network analytics to try and create a new set of metrics, a new set of measures to analyse this network and see how it affects the tissue, how it affects the behaviour and the function of the human brain. I'm hoping through this new perspective we can start to analyse things like risk factors for antiplatelet therapies, the development, the chicken and egg problem of brain tissue and vasculature and Alzheimer's disease, and all manner of new characteristics. By applying an objective measure, something that we can apply across any brain, instead of getting an expert to analyse slides for hours, we can start to look at huge scale studies, tens of thousands of people over many years, and see the whole network, not just the largest arteries. Through this approach, I'm hoping to shed insight on these important aspects, things like aspirin in the elderly, that we don't fully understand because we can't look at the network as a whole. And hopefully through this approach, shed some light on the devastating disease, Alzheimer's. Thank you very much.
Thank you.